Transformations and translations. In this video, transformations and translations of trigonometric functions will be discussed. Let's start by looking at the equation and graph of a trigonometric function in the form y equals a sine k x minus d plus c. The default equation can be written simply as y equals sine x. And this is what the graph of a sine function would look like. In this video, transformations and translations of trigonometric functions will be discussed. What is a transformation? A transformation refers to the change of a graph where the shape of the graph changes. It could get bigger, which is called a stretch, or it could get smaller, which is called a compression. This effect makes the graph look smaller. This is an example of horizontal stretches and compressions, and this is an example of vertical stretches and compressions. Now, let's start by looking at the default values of the equation y equals a sine k x minus d plus c. The amplitude, which is of course the height from the axis of curve to the maximum point or the minimum point, has a default value of 1. So a is equal to 1. The axis of curve, which is the horizontal line cutting the graph into two equal parts, is found where y is equal to 0. The period is the length of one cycle or one pattern in the periodic behavior. Now we have a formula to find k. K is defined as being 2 pi divided by the period. Since the period length of a default graph is 2 pi, we get the equation 2 pi divided by 2 pi, which would give us the value 1. D represents the horizontal starting point. At this point in a default graph, the coordinate is equal to 0, 0. The horizontal starting point, you need to look at the x value of the coordinate. Just to review, the default values, a is equal to 1, c is equal to 0, k is equal to 1, and d is equal to 0. In the real world, nothing ever follows the default settings. There is always ways in which the function can change. There are 4 ways that you can change the graph of a trigonometric function. The first is a vertical translation. This means the axis of curve can move up or down depending on the application. Vertical transformation. The amplitude of the applications either stretches, gets bigger, or compresses, gets smaller, depending on the application. Horizontal translation. This means the x value of the starting point can move left or right. And we have the horizontal transformation. which means the period of the application changes, causing either a stretch or a compression of the period length. As we work through the next part of this video, you may wish to try these transformations and translations using your graphing software. Now, we'll talk first about the vertical translation. And here are the steps you're going to follow. Draw the graph for y equals sine x. Draw the graph for y equals sine x plus 3. Draw the graph for y equals sine x minus 3. We're going to compare the results. How do these graphs change the shape of the image? Let's start by looking more closely at the graph y equals sine x. And we notice the default settings. A is 1, C is 0, K is 1, and D is 0. We're going to look a little more closely at the default value of C. It will be the axis of curve that we will notice moving in a vertical translation. Now, let's look more closely at the graph y equals sine x plus 3. The green graph indicates y equals sine x plus 3, and the dark blue, purplish color, indicates y equals sine x. What has changed in the graph? The value of C is now 3, as we can tell from its position of C in the equation. That means the axis of curve is at y equals 3. And if we draw a horizontal straight line, we notice that, yes, it is at y equals to 3. So by adding a number at the end of the equation determines the position for the axis of curve, which means our whole graph has moved up. Now, what happens for y equals sine x minus 3? And here it's shown on the graph in blue. The value of C from the equation is now negative 3. The axis of curve would then be y equals negative 3. If we draw a horizontal ruled line, we notice, oh yes, it passes through y equals negative 3. So our graph has vertically translated down by a factor of negative 3. Now, the rules to follow. If C is greater than 0, the graphs of sine x plus C or cos x plus C are translated upward by C units. But if C is less than 0, the graphs of y equals sine x minus 3 or cos x minus C are translated downwards by C units. Now we're going to look at vertical transformations. And we're going to analyze y equals sine x first. And we all recognize this default graph, which has an amplitude of 1. Now we're going to look at vertical transformations. We're going to look at the equation y equals 3 sine x and its comparative graph. This graph is shown in the magenta colored graph on the right-hand side. The value of 3 from the equation and the position is now 3. The amplitude is 3. So we can make the connection that the number in front of sine does represent the amplitude. And this represents a vertical transformation by a factor of 3. Now, let's look at vertical transformations. Y equals 1/3 sine x. This is shown in the graph by the aqua turquoise color. The value of A is now 1/3. The amplitude, as shown in the diagram, is 1/3. Yes, they match. The amplitude 1/3, A is 1/3. This represents a vertical transformation by a factor of 1/3. For vertical transformations, what are the rules to follow? If A is greater than 1, the graphs of y equals A sine x and y equals A cos x are stretched vertically by a factor of A. The amplitude of each function is A. If 0 is less than A, which is less than 1, the graphs of y equals A sine x and y equals A cos x are compressed vertically by a factor of A. The amplitude of each factor is A. Horizontal transformations. Y equals sine x is our default equation, the graph. The value of k is equal to 1. The period length is 2 pi. Horizontal transformations. Here's the equation we're going to analyze. Y equals sine 2x. Shown in the graph in green. The value of k is 2. The period is 2 pi divided by k, which is 2 pi divided by 2, which is pi. The period length is pi, shown in blue. This is a horizontal compression by a factor of 1/2. Some people find this a little confusing. If the value of k is 2, you would think it's a stretch. But keep in mind the definition of period. The value of k becomes the denominator, which makes it a compression. Don't be tricked by this. Horizontal transformations. Y equals sine 1/2 x. This is shown in the graph with the orange line. The value of k is 1/2. The period is 2 pi divided by k equals 2 pi divided by 1/2, which is 4 pi. The period length is 4 pi. This would result in a horizontal stretch by a factor of 2. So what are the rules? The period of each function is 2 pi over k. If k is greater than 1, the graphs of y equals sine kx and y equals cos kx are compressed horizontally by a factor of 1 over k. But if 0 is less than k, which is less than 1, the graphs of y equals sine kx and y equals cos kx are stretched horizontally by a factor of k. Horizontal translations. Y equals sine x, our default graph. The value of d is 0. The x value of the starting point is 0. Horizontal translations. The analysis, y equals sine bracket x minus pi over 4 bracket. The d has to always be in a bracket with the x value, a single x value. More about that later. The graph is shown here in green. The value of d is pi over 4. The direction is to the right. This is another little trick. If the sign in the bracket is negative, the direction is to the right. If the sign is positive, the direction is to the left. Don't be confused. The value of the starting point is pi over 4, the value given in the equation. The horizontal translation has been to the right, pi over 4. Horizontal translations. Y equals sine x plus pi over 4, shown in the graph by the magenta graph. The value of d is negative pi over 4. Remember the rule, x plus pi over 4 comes outside the bracket to be x equals negative pi over 4. The direction is to the left. The x value of the starting point is negative pi over 4. The horizontal translation has been to the left, pi over 4. Horizontal translations, rules to follow. If d is greater than 0, the graphs of y equals sine x minus d and y equals cos x minus d are translated d units to the right. If d is less than 0, the graphs of y equals sine x plus d, y equals cos x plus d are translated d units to the left. Now it's time to practice these concepts. Coming in future videos you'll need to watch how to find the coordinates on a horizontal transformation, how to combine transformations and translations.